Hello students, welcome to this session. I have today solved this physics paper of JEE Main Test 67. Now I am with the analysis of that. So the paper was I can say a perfect JEE Main paper. You were questions that were actually easy, questions that were actually difficult, and the medium it's a right mix. So it should be good paper. Everyone will find questions of their caliber to be get solved from this. I have regarded 4 questions as tough, 10 as medium, and 11 as easy. Question number 23, answer given by them is wrong. They have taken the reverse case. I have explained it when I have solved that. So all in all, it is a good paper, and I suppose there is something for everyone. So here I can say a good student should get 60 score, and a very good student again should get 80-85 plus scores in this particular paper. So let's see what is in the paper. So let's start. A hydrogen atom initially in the ground level absorbs a photon which excites it to an equal to 4 level. Okay, so 1 to 4. Determine the wavelength of the photon. So directly I can say that would be equal to R. And what we have said, or let's say directly go with energy. I am more comfortable in doing that. So if I do n equal to 1 to n equal to 4, the difference of energy that we talk about is minus 0.85 minus becomes plus 13.6. that is the difference. So this difference comes out to be what we have 5 and 15 and 8 7. This is 12.75 ev, that is hc by lambda. So lambda comes out as 1240 upon 12.75. that was ev nanometer, so ev cancels, it comes out in nanometer. So it would be less than 100 nanometer, it would be slightly 90s nanometer something. So it will go for 9.8 into 10 to the power minus 8 meters. Next, after a perfectly inelastic collision between two identical particles, okay, perfectly inelastic, moving with the same speed in different direction, the speed of the particles become half the initial speed. The angle between the velocities of the particle before the collision is, okay, so let it the angle be, let both be coming like this. This is v, and let's say this angle be theta. So what we can say particularly, finally we will know it will go like this. Okay, so if I take the components along that particular direction, because let's say this is x, this y will cancel out. So along x it was mv cos of theta by 2 times 2, that would be equals to 2m, and final velocity is half of that, that is v by 2. So what we get, 2mv. So cos of theta by 2 comes out as half. That means you know theta by 2 is 60 degree, that means theta is equals to 120 degrees. So go for option C. You could directly do it from vector analogy also. Two vectors of equal magnitude produce a vector of same magnitude only if they have an angle of 120 degree between them. Next, a light rod of length L is hanging from the vertical smooth wall of a vehicle moving with this acceleration along the horizontal plane, having a small mass attached to its one end and is free to rotate about an axis passing through the other. Okay, the minimum velocity given to the mass at its equilibrium position with respect to the vehicle so that it can complete vertical circular motion. Okay, so just look at it. Let's say the vehicle is moving forward with some acceleration. This is a0, which is given as root 3g. So first of all, the equilibrium position would be like this. This is a small mass, it's almost a pendulum situation, and what we will have, applying the pseudo force, this is ma0, this is mg, and that would be the tension. So if you do this, what you will have, you can directly make out t cos theta equals mg and t sin theta equals to ma0. So what we get, tan theta is a0 by g. That is the equilibrium position it will have, that is 60 degree. Now, the minimum velocity given to the mass at its equilibrium position with respect to the vehicle so that it can complete vertical circular motion. Because it is a rod, there is no tension of it losing the path. So you have to just make sure that it goes up. It goes up. So while it goes up, what happens here, in the frame of that, there is a constant force ma0, there is a constant force mg. So when it goes up like this, whatever, so when it its highest point, you will see this force will also do some work, and this will do some negative work also, because it has moved along that. So there will be some work done. Now here it would be more better, let's say if I see, because of this ma0 and this mg, I can say the effective g will be now in this direction, and the effective mg that I can make out, that effective mg or the effective g directly I can say would be equal to g square plus a naught square under root, that is 3 plus 1, that will come out as 2g. So what we'll say for this, taking the same analogy like that, because this force is going to remain constant here, the instead of that topmost point I will look for that point, and I can, you can say I can just tilt the figure, tilt it figure, and it is our normal figure now. So it goes up by distance 2l, and let's say this velocity be v minimum. So at this point this velocity is 0. So here this point is this one, I have tilted it. So by going this 2l distance with an effective acceleration 2g like that, I can again go for the same analogy that we had, what v equal to 0. So just applying energy conservation, what I can say, that half m v min square would be equal to m g effective. G effective here becomes not g, it will become 2g, and the height with respect to that direction would be 2l, not the exact height but the length we can say here. So this v minimum comes out as, v min square comes out as 8gl. So this is a very good question. So just we have converted this, effectively I have taken this to be my new vertical and I have gone for that. So it's a very good question. Next, an AC EMF 4 cos 1000 eV is applied to an large circuit containing inductance and resistance. The amplitude of this circuit is, so what we have, first of all, what is XL? XL would be 1000 into 3 into 10 to the power minus 3. This comes out as 3 ohms. R is 4 ohms. So Z you can make out is R square plus XL square. You know that would be equal to 5 ohm. So now what would be the amplitude? I max is V max by Z. V max is 4, that is 4 by 5. This goes by 0.8 ampere. So it's an easy one, not a tough one. Okay. Next, the question number 5 will go for. We have 4 identical capacitors connected with a battery of voltage V, 2 switches as shown in figure. Where are the switches? Okay, here are the switches. Initially K1 is closed, K2 is now K2 is also closed. Find the heat loss. So when K2 was open, this was out of the circuit, and what we had, this was short circuited. So effectively only this capacitance was working. So the energy in the circuit was half CV square, and the charge which it on this capacitor Q was equal to CV. Now if K2 is also closed, now the situation will, what the situation will now become, the situation will now be, it would be somewhat different. What I can say, this is A, this is A, this is B, and let it be, let's say this is point is, let's say let's call it C only, or let's call it M only. Okay, so now redrawing it, this is A and B, the battery is there, and let's say there's some M point here. So what we have, this is A and M, this is C, and this again M and A, that is C. Then we have A and B as C, and we have M and B at C. So now what we have now, this is in parallel to C, this is C in series, so it comes out as 2C by 3 plus C, that is 5C by 3. So final energy would be half 5C by 3 into V square. That basically comes out as 5CV square by 6, plus the final charge that is basically on the system would be, and the equivalent is 5C by 3 into V. So the charge flown from battery is 2 by 3 CV. So WB is equal to delta U plus H, you know. So that charge is 2 by 3 CV into V. Delta U would be half, that is was 5 CV square by 6 minus CV square by 2 plus H. So if I do the calculation, what it comes, H comes out as, it is 2 by 3 CV square plus CV square by 2 minus 5 CV square by 6. Take LCM as 6. This will be 4, this will be 3, 7 minus 5, that is 2 CV square by 6, that is CV square by 3. Go for option C. It's a very good question that is given in your test. Now the following figure gives the movement of an object. Okay, so an object is moving like this. Select the correct statement. Total distance traveled by the object is, okay, so total distance you need to calculate all those areas. First of all, this area, this is half into 10 into 15, that is 75. Now this area, this would be 15 into 5, again this is 75. Now what we have, this I can, let's say, calculate like this till this. So this area, it would be 15 to 45, that is 30. 30 into 15, that will come out as 450. So 450 plus 150, that is 600. We have already done. Now this triangle would be half into 20 into 5, that is 50. Half into 20 into 5, yes, it is 50. So it is 650. Now if I do this, what we have, this triangle, now this triangle would be 10 into 25 by 2, that is 25. 5s are 125. So 650 plus 125, what we are getting now, we are 650 plus 125, that is 775. We have got till now. Okay, now this one, this strip would be 5 into 10. 5 into 10. Okay, so this is 50 again, so it is now 825. Now this strip again 50, this would be 875 now. And now this triangle, this is 10, and this is 20. 200 by 100, that is 100, so it is 975. So go for this. So we have calculated, and luckily the first option has come. Okay, next. The escape speed of the body projectile on Earth's surface is 11.2. We all know body is projected out with thrice its speed, that is the speed far away from the Earth would be. So what we can say, far away speed, let's say it would be v. So half mv square minus v square, that is a loss in what we say the kinetic energy, that would be gain in potential energy, which is finally 0. Initial it was minus gmm by r, so it was gmm by r, and this gmm by r, you know, is equal to half mv escape square. So what we have, half mv square minus v escape square, we should write it reverse, sorry, it is because it is a loss, it should be right v square initial, sorry, u square minus final square, because v escape is not written here because it is given with thrice the speed, u square minus v square. So what we have, u square minus v square is equal to v square. So v square would be u square would be 9v square because thrice of that. So that would be equals to root 8 times v. So root 8 times v, that is root 8 into 11.2, that would be 30 less than 33. It would be less than 33. So closest option is 31.7 kilometer per second. So we'll go for option D. Now next, question number 8. Which of the following cylindrical rods will conduct maximum heat, okay, when ends are maintained at same temperature? So what we know, just calculate the thermal resistance. We know thermal resistance is L upon K. So because cylindrical rods, K is not given, it's assumed it is same. So R is proportional to L upon area, that is L by R square. So check for L by R square. This is 1 upon 0.04. This is 1 upon 0.01. This is 10 upon 0.01. This is 0.1 upon 0.09. Okay, so if I do this, this is 100 by 425, this is 100, this is what we will have, this will be 100, or it would be 1000. Okay, and this would be, what we can say, it is 1 upon 0.9, 10 by 9. So for maximum heat, R should be minimum, so R should be minimum, it is minimum 10 by 9, so maximum heat will go from D. Next, for which combination of working temperatures the efficiency of Carnot engine is the least? Okay, so what we have, Carnot engine efficiency in eta C is 1 minus Tc by Th. So for the first one, it is 1 minus 80 by 100, it comes out as 1 by 5. This is 1 minus 20 by 40, it comes out as 1 by 2. That is 1 minus 60 by 80, that is 3 by 4, 1 by 4. This is 1 minus 40 by 60, that is 2 by 3, 1 by 3. So minimum is 1 by 5. So I'll go for option A, that is 100 Kelvin, 80 Kelvin. Now, next one. After 9th, a thin flexible wire of length L is connected to a battery. Okay, negligible as compared to the wire. Okay, if to form a closed loop, the battery drives a current I. When the system is put in a field of strength B perpendicular to the plane, it will take the shape of circle. We know the tension in the wire is. So we all know this particular concept very much. When it takes a shape of circle, we take a very small section here, subtending an angle theta. We take this equal parts, take this angle to be theta by 2, and see this only this section. So the section's length dl would be equals to r d theta. This force T here, this force T here, and the B force would be outwards like that. That would be equal to BIL, L is BIDL. So what we have, BI into R d theta would be equal to, if I do this components, this would be sine components, so 2T sine of d theta or delta theta or d theta by 2. Let's say d theta by 2 I should write, and because it is small I can write sine theta as theta, so theta goes. So BIR is equal to 2T by 2. So what we get now, what we will get now, tension is equal to BIR, and what is R? We know the total length 2 pi R is equal to L, so R is equal to L by 2 pi. So we'll go for BIL by 2 pi, go for option C, that is the appropriate one here. So this is a very common concept, you all should know this. Next, a train of 150 meter length going towards north at a speed of 10, parrot flies at 5 towards south direction parallel to the railway track. The time taken by the parrot to cross, because both are in opposite direction, we know V relative is going to be 15 meter per second and the distance relative is 150, so time would be 150 by 15, that comes out as 10 seconds. Again, not a tough one, it's an easy one. Such profile you have done that monkey question in your NCERT chapters. Photon of energy 10.2 corresponds to light of lambda naught. Okay, due to electron from 2 to 1, the light of wavelength lambda is emitted. So 2 to 1 gap is 10.2, that is simply lambda naught. If we take into account the recoil of the atom when the atom is when the photon is emitted, then so if we take that into account, generally for 2 to 1 we assume the complete energy goes with photon. If the recoil is taken, the energy will slightly be decreased, so lambda will slightly be increased, so lambda is going to be greater than lambda naught, so go for option B. Next, the level of water in a tank is 5 meter high, a hole of the area is made in the bottom, the rate of leakage of the water, so that is dV by dt, rate of leakage, that is A into V, and we know simply V is equal to root 2 GH from that Torres-Lilly's law. So area is 10 centimeter square, this is root 2 GH, so 10 into 5, so this is 10 10 10, so it is 10 to the power minus 2 meter cube per second in SI units, so it go for option A. Now the next one, a pendulum is oscillating with an angular amplitude of 90 degree. The value of angle alpha made by the string with the vertical at which the acceleration is directed horizontally. Okay, so acceleration is directed horizontally. So here if I look at any angle like this, the acceleration, one component is, let's say this is AC and one component we say is AT. So for it to be horizontal, the both this things in vertical must cancel out. So let's say this angle be alpha. So what I can do, if I draw the FBD, I have this force mg and I have this force T. Okay, so let me rub it now. So because in the vertical there should be no acceleration, so the forces must be balanced, let's say, or instead of force balancing, let's say I say this is AT and let's say AC and this is AT. So this angle is alpha, this is alpha, this will be definitely 90 minus alpha. So first thing I can say is AC cos alpha should manage AT cos of 90 minus alpha. So what I can say, AT we already know will always be equal to G sin alpha. So that G sin alpha into sin alpha, that is G sin square alpha, should be equal to AC cos alpha, and AC is V square by R, cos alpha equals to G sin square alpha. This is the first thing I've got. Now from the energy analysis, the height it has lost, this height h, that is basically L cos alpha. So L cos alpha into 2G, that would be equal to V square, because we know V square is 2GH. So what is V square by L? From here I can write it as 2G cos alpha. Substitute it here, what we'll get, 2G cos square alpha equal to G sin square alpha. That is what I'm getting. Let me check. Yes, I'm still right. So now what I have left, what I have left with, I'm left with is GG goes, so 10 square alpha comes out to be 2, so 10 alpha is root 2. So 10 alpha is root 2. So if 10 alpha is root 2, there's no option like 10 alpha. So I can say this is root 2, this is 1. So going by the analogy, this would be root 2 by 1. So 2 square plus 1 square, that is root 3. Sorry, excuse me. So what I can say, cos alpha is going to be 1 by root 3. So alpha is going to be cos inverse 1 by root 3 from this analysis. So go for option C. So it's a good question, interesting one. Next. In a common emitter NPN transistor, 10 to the power 10 electrons enter the emitter in this second. So this is basically the emitter current. Emitter current is 10 to the power 10 times C upon 10 to the power minus 6. Okay. So what I let it be like this there. About 5% of the electrons recombine with the hole. So the current gain is okay. So there's no such issue for that. We have a common emitter. We know the current gain beta is equal to IC by IB. Now this is 5% of IE, so this would be 95% of IE. So there's nothing to do, 95 by 5 directly 19. We need not to do those calculation which I was initially doing. Next, 1800 watt toaster, 1.3 kilowatt electric fan, 100 watt lamp are plugged in the same circuit. all are in parallel, what is the approximate value of the current? So because all in parallel, the total power would be P1 plus P2 plus P3, no issues in that. So total power is 1800, 1.3, that is 1300, 3100 plus that is 3200 watt. That would be equal to I total into V. So I total would be 3200 upon V. V is 120. So 320 by 12. Do this. This is 24 and 80. 80 would be, let's say, 6 72, and then again 80, so 26.66 ampere. That is, we are going to get it. So approximation would be 27 amperes. Go ahead. Next. If velocity is a by t plus b by t square plus ct cube, then the dimensional formula of B is, because it is velocity, I can directly say dimensional formula of B is V by T square. So V is LT minus 1, so it becomes LT minus 3. So LT minus 3, we are going for option D, that is the only appropriate one. I can see next one. As shown in figure, wheel A of radius 10 cm coupled by belt B to wheel C of 25, okay. Angular speed of A is increased at a constant rate, the time after which wheel C reaches the rotational speed of 100 rpm. So first of all, we know, because this length is fixed, so these 2 points velocities must match out. That means omega A RA must be equals to omega C RC for no slipping condition. So what I can say, write omega C would be equal to omega A into RA by RC. Okay. So and omega A is alpha A into T, because it is starting from rest, RA by RC, and you have to do it to be 100 rpm. RPM means 2 pi by 60, you know. So this becomes 5 by 3 into 2 pi. Alpha is 1.6. Let me write it is 1.6 only, into T, and RA by RB is 10 by 25. So RC, that is 10 by 25, that is 2 by 5. So 1.6 into 10 by 25 T is 10 pi by 3. So T comes out as 10 pi into 25. This is 16. 3s are 48. So now what we are left with? So it is nearly, you have to check out. So let me cancel it. It is 5. This is 24. So this is 125 into 3.14 upon 24. So approximately it would be 5 into 3, 15 or 16 something. That would be the answer. So 16 second you can do for approximation value. Next. A person stands on the platform and one train is approaching, another one is going away with same speed. Frequency of the sound produced by train is this. What would be the number of beats? So for the one which is coming towards it, it will hear 240 into, because train is moving, source is moving, that would be 300 upon 300 minus 4. For the second one, it would be 240 into 300 upon 300 plus 4. So if I do that difference, that is F1 minus F2, that will approximately come out as, you have done these things, you can directly say it would be 240 into 2 into 8 by 300 approximately. You can make it out. Okay, 2 into 4, sorry, 8, I already did this. Or let's say do it, and I don't used to apply that formula. Let me derive it for you, because I don't know if you remember that or not. So taking 240 into 300 as common, what we are left with? 1 upon 296 minus 1 upon 304. So what it is? 240 into 300 into what you will have, 8 upon 296 into 304. So what it approximately yield, this is, if you are doing the approximation is, let it be 300 into 300, 1 is cancelled. So what we have, 240 upon 300 into 8, approximately it would be like this, because the difference is very small, and this is 4 by 5 into 8, that is 32 by 5. So 32 by 5 is approximately 6. So the beat frequency would be nearly 6 beats per second you are going to hear from it. Okay, next one. A body which starts from rest is moved along a straight line by a machine delivering constant power. The distance moved, because power is constant, kinetic energy of time T is Pt, K is half mv square. This is a very general question. So V square is proportional to T basically. So V square is proportional to T, so V is proportional to root T. Displacement we say is V dt integration, so definitely that would be proportional to T to the power 3 by 2, because T to the power half integration will give you T to the power 3 by 2. So it is C. So we are done with the straight objectives. Now the subjectives. In the circuit, resistance of each arm is 100. Okay. Find the resistance in ohm to the nearest integer which is to be connected between C and D, so that the resistance of entire circuit between A and B doesn't depend on the number of elementary cells. Okay. So let that connected resistance be R0. So now, using the symmetry, there should be independent of number of cells. That means if there are no cells, then it would be equivalent would be R0. So for adding cells, it still should remain R0. That means the equivalent across AB should also be equals to R0. That is the important thing. So RAB should be equals to R0. This is important. otherwise you cannot have that. You might have done such questions in numerical values based on some small number of resistors where after every branch the value repeats itself. This is a question of that sort. So now what we need to do, so this is R0, so what I can write here, so it is independent of the number of cells. So let's start is RAB is equals to R0, and let's say do this like this is R, and let's say between these 2 points will also be R0. So let's say this would be again equals to R0, and let's say this is again R, and let's say what it becomes, this is R, this is R, this is R, something like that. So this is the equivalent thing that we will now get here. So now what we'll have, this branch is equal to, this is a straight line, this would be 2R plus R0 in series, and this is with R, so 2R plus R0 into R upon this would be 3R plus R0, and this should be equals to R0. This is how you can do. So 2R square plus RR0 is equal to 3R R0 plus R0 square. So what we have now, we have R0 square, we have plus 2R R0 minus 2R square equals to 0. So if I do this, there won't be such easy factors. I need to do the quadratic one, minus 2R. I won't take the negative values, only plus 4R square plus it would be 8R square about 2. So it would be 2, I'll take out, it is minus R plus 12, so 4 goes out, so it is root 3R. So it is R times root 3 minus 1. Okay, so R0 is R times root 3 minus 1. What is R? 100. 100 into 1.73 I can do. So this is 173 minus 1, so it would be 73. So it's a very nice question. You need to get the logic right, otherwise it would be a tougher one. Next one. Body of 64 Newton is pushed with just enough force to start it moving along horizontal floors. That means that is Fs max. And same force continues to act afterwards. So once it moves, this F is Fs max. Now the friction would be Fk. So acceleration would be Fs max minus Fk by m, which you directly remember as mu s minus mu kg. This is a very important elementary question. So that is 0.2 into 10, that is 2 meter per second square. So you can directly go for this. This is the thing that is being generally taught in the friction chapter everywhere. Next. Sample contains a large number of nuclei. Probability that a nucleus in the sample will decay after 4 lives is A by V. So it will decay after 4 lives. That means it should survive 4 half-life. So survival probability for 4t half is equal to 1 by 16. So this 1 by 16 is the survival probability, and then it will decay. So it will decay after 4 half-lives would be, you can say it is 1 by 16 thing. So if you add it, what you get, the sample will decay after 4 half-lives is A by B. So the value of A by B for me comes out to be 70. Here the answer by NTA is wrong. They have taken it to be the probability that it decays in 4 half-lives. So they have done 15 by 16 and 31 is given. It is wrong. It should be 17. Which they should have read that language properly. Next. SHM 1 kg mass connected to a horizontal spring performs SHM with A. While mass M1 is passing through mean, another mass is placed on it. So both move together with amplitude A1. The ratio of A1 by A2 is. So it is passing through the mean. So when it was passing through the mean, there was no external force and it just sticks. So now what happens? The new Vmax will be, you can say, momentum conservation because no external force along horizontal. So 4m Vmax, because it is 3 kg, I have taken M1 to be m and M2 to be 3m. That V2 equal to m V naught max. That is the initial max velocity. So what we have, the new max velocity is equal to V naught max by 4. And V naught max, you can write it as omega naught A upon 4, and new Vmax would be nu omega into A1, that is omega naught A by 4. So A would be A by 4 into omega naught by omega. Now what is omega? Omega, you know, is equal to root of what you can say K by M. So M has become 4 times, so new omega will become omega naught by 2. So it will become 2A by 4, that is it will be A by 2. Sorry, A1 I am writing, so A1 would be A by 2. So the ratio of A1 by, it is 1 by 2, and you can write it as 1 by 4 ki power half. So this is 1 plus 4, and this comes out as 5. Next one. The maximum refractive index of a prism which permits the passage of the light through it is root n. If the refracting angle of the prism is 90 degree, what is the value of n? Okay. Maximum refractive index of a prism which permits the passage of light through it. Now when light passes, we know the two angles R1 plus R2 is equal to A. Okay. And from here all light should pass. All light should pass. That means this neither of the angle should breach the theta c. That means for the limiting case, what I can have, theta c would be a by 2. The limiting case, theta c is equal to a by 2, that is 45 degree, and for corresponding to that theta c 45 degree, what we can have the value, we have sine 45 is 1 by n, so n comes out as root 2, so the answer is going to be 2. That is the only viable thing that we can do. You just can check out that diagram again. This is 90 degree, so whenever any light comes, you know, it goes like this and then it goes like this. This angle is r1, this angle is r2. You know, r1 maximum is theta c, r2 maximum is theta c, so their maximum value is 2 theta c, that is in limiting case is a, so theta c comes out as a by 2, and we can go for this particular concept. So this was today's paper. So paper was a good one, I suppose. So thanks for watching. Keep sharing the channel, keep giving your feedback through the comments. Thank you once again.